Have you ever stood in the canned food aisle and felt a quiet sense of disbelief? Row after row of metal cylinders sit under bright grocery store lights. Inside them are beans, peaches, soups, tuna, tomatoes. Some have been there for months, some for years, and yet they look unchanged. No mold creeping across the surface, no sour smell escaping into the air, no visible sign that time has touched them at all. In almost any other setting, that same food would begin to decay within days. Leave a bowl of soup on your kitchen counter, and by tomorrow it will be unrecognizable. Leave fresh fruit in a warm room, and nature immediately begins its work. The air fills with a faint sweetness, then a sourness. Surfaces soften, colors darken. Something invisible begins to take over. So why does this simple metal container seem to pause that process entirely? Most of us have been told a simple explanation. As long as the seal isn't broken, it's fine. It sounds reassuring, but what does that really mean? And why is a tight lid enough to stop something as powerful and inevitable as decay? To answer that, we first have to understand what spoilage actually is. Food does not rot on its own. It is consumed. When meat turns sour or vegetables grow fuzzy with mold, it is not because the food has decided to decompose. It is because microscopic organisms are feeding on it. Bacteria and fungi are everywhere. They live in soil. They float through the air in dust particles. They rest on your hands, your knife, your kitchen counter. The moment food is harvested, it becomes part of this vast microscopic world. If conditions are right, warmth, moisture, nutrients, those organisms begin to multiply. One bacterium becomes two become four. Within hours, the numbers can reach into the millions. As they grow, they break down the food's structure to extract energy. That breakdown produces gases, acids, and compounds that alter smell, texture, and taste. What we call spoilage is simply life feeding on life. So the real question is not why canned food doesn't rot. It is why nothing inside the can is alive to eat it. There is a widespread belief that canned food lasts because there is no air inside. We instinctively associate life with oxygen. Humans need it. Flames need it. It feels intuitive that bacteria would need it too. But biology is more complex. While many microorganisms rely on oxygen, others do not. Some species are perfectly adapted to environments where oxygen is scarce or entirely absent. These are known as anaerobic bacteria. For certain anaerobes, oxygen is not helpful. It is harmful. One of the most serious examples is Clostridium botulinum, the bacterium responsible for botulism. It thrives in low oxygen conditions. If all we did was remove the air from a container and seal it, we would not be preventing danger. We might be encouraging it. So the absence of oxygen is not the secret. Yet the real reason canned food lasts for years is far more definitive. The interior is sterilized. Before sealing, the food is heated to temperatures high enough to destroy microorganisms, not only active bacteria and fungi, but also their most resilient survival forms. And this is where the science becomes quietly impressive. Some bacteria can transform themselves into spores. You can think of a spore as a biological survival capsule. When conditions become harsh, extreme heat, dryness, lack of nutrients, the bacterium encases its genetic material in a protective shell. In this dormant state, it can survive conditions that would instantly kill most living cells. Boiling water reaches 100 degrees Celsius. For many microbes, that is sufficient, but certain spores can endure boiling temperatures for extended periods. Simply boiling food and sealing it would not guarantee safety. This is why industrial canning relies on pressure. By using pressurized steam, manufacturers can raise the temperature inside the sealed can to around 121 degrees Celsius. That additional heat makes a profound difference. At this level, even tough spores break down. Proteins unravel, cellular structures collapse. Genetic material is damaged beyond repair. The process is precisely timed and carefully controlled. The goal is not merely to cook the food, it is to achieve commercial sterility, a state in which no viable microorganisms capable of causing disease or spoilage remain. When this process is complete, the interior of the can is not just oxygen poor, it is biologically empty. But sterilization alone would not be enough if contamination could return. This is where the seal becomes essential. In the 19th century, Louis Pasteur demonstrated that microorganisms do not appear spontaneously. They come from other microorganisms. They travel invisibly through air and dust. If sterile material is exposed, it becomes contaminated. If it is protected, it remains sterile. Canning applies this principle with precision. Food is sealed in its container and heated. As it cools, the contents contract. This creates a partial vacuum inside the can. The lid is pulled slightly inward, forming the familiar concave shape. That indentation is not what preserves the food. It is evidence that the barrier is intact. As long as the metal walls and seams remain undamaged, no external microbes can enter. No airborne bacteria can drift in. No fungal spores can settle. The can becomes a closed system, separated from the living world outside. In a sense, the can does not stop time. It simply prevents life from interacting with the food. And yet, even in this carefully controlled environment, change still occurs. There is a difference between being safe to eat and being identical to the day it was sealed. Even when all biological activity has been halted, chemistry continues. Food is made of complex molecules: proteins, fats, sugars, pigments. Over time, these molecules can slowly react with one another. Fats may oxidize in small amounts. Colors may dull. Textures may soften as structures gradually shift. Acids present in certain foods, like tomatoes or fruits, can interact subtly with the can's lining over many years. Manufacturers design protective coatings to minimize this, but chemistry cannot be entirely paused. These changes happen slowly. They do not signal danger. They simply reflect the quiet persistence of chemical processes. This is why canned foods are labeled with best buy dates, rather than strict expiration deadlines. As long as the can remains sealed, undented, and properly stored, the contents are generally safe far beyond that date. Quality may decline, but sterility remains. When you step back, the achievement is remarkable. Canning reshaped human history in ways we rarely consider. It allowed food to be transported across oceans without spoiling. It made long military campaigns and exploratory voyages possible. It supported the growth of cities that no longer relied entirely on immediate harvest cycles. But perhaps more importantly, it introduced predictability into everyday life. Before reliable preservation, food availability was deeply tied to season and geography. Surpluses were temporary. Scarcity was common. Canning helped create stability. It reduced waste. It allowed households to store nourishment safely for months at a time. And it accomplished all of this with a simple principle: eliminate the organisms that cause decay and prevent new ones from entering. Now, the next time you pick up a can of soup or vegetables, you may notice something subtle. You are holding a carefully engineered environment, a small, sealed space where biology has been deliberately suspended. Inside that metal container is not just food, but the result of precise heating, pressure, and an understanding of invisible life. Decay feels inevitable because, in most cases, it is. Nature reclaims what is exposed. Microorganisms are patient and persistent. Yet with heat, pressure, and a secure seal, we found a way to interrupt that cycle. Not by defying nature, but by understanding it. Thank you for watching. If there is another everyday object you have always wondered about, feel free to share it in the comments. And if you found this explanation helpful, consider liking the video and subscribing. There is often more happening in ordinary things than we realize.